Very good evening, everyone. This is the second lecture for the protein. Okay, we are completing proteins, lecture number 2 under the biomolecule. Okay, so till the last lecture, we have discussed about the properties of alpha amino acid, or you can say properties of protein. And the last topic was deuterion, crystalline solid formation because of deuterion. Okay, so welcome back, guys, once again. This side your chemistry faculty Govind, and now we are going to discuss about the lecture. So here once again I am telling you about the deuterion. In the case of deuterion, children, what is deuterion? R CH CO minus and here NH3. This kind of a species is called deuterion. This is the deuterion. Okay. Now we are going to discuss the three states of deuterion. What we are going to discuss? Three states of deuterion. So what are the three states? Three states of deuterion. So be with me. Definitely it is going to be very interesting. So what is the deuterion, children? R CH COO minus and here NH3 plus. That is the deuterion. It's a deuterion. In that case, if this deuterion is reacting with any acid H plus, so what happened? Tell me, according to your view, that H plus will be attracted by the this negative species. It will be attached here. So what you are getting now, R C and NH3 plus. So that is the one state of deuterion. It is acidic or basic, children? Because of the presence of COH, it is acidic. What is the nature? Acidic nature. Then pH is less than 7. pH is less than 7. At the same time, if you have adding this solution, you are doing the electrolysis of this solution, then what happened? Here cathode, positive sign, negative sign. So it is your anode and it is your cathode. So tell me one thing, where the ion will be liberated, at the anode or at the cathode? So these ions, this deuterion liberated on the cathode, because here the positive charge is present. Because of this positive charge, they will be liberated on cathode. Okay, that you have to write here. They will be liberated on cathode. At the same time, if you are adding OH minus, what you are doing, OH minus, then what happened? OH minus will take one hydrogen from here and water will be removed and the species formed, that is RCH minus, and here NH2. In that case, what is the nature of this species? It's a basic nature. Why basic? Because the presence of NH2, then pH is greater than 7. Same work if you are doing here, electrolysis. If this solution you are putting in the container and doing the electrolysis, so what happened? This is positive terminal, this is negative terminal. So ion this time will be liberated on anode, because anode is a positive terminal. Okay, and the negative charge is present here, this negative charge. Same work for this deuter ion. If you are doing, if you are putting this solution in the container and applying cathode and anode, then what happened? Positive, negative, this is your cathode and this is your anode. So what happens, children? Where it will be liberated? It will not liberated anywhere. It will not liberated anywhere. Why? Because this time pH is 7. This time pH is 7 and both positive and negative ion present at the same compound, so it will not be liberated anywhere. And this is called isoelectric point. What it's called? Isoelectric. Isoelectric. Okay, at this point pH is 7. So this is the deuter ion, children. Once again I am explaining here. In the deuter ion, if you are adding acid, then it is converted into acidic solution, and if you are doing the electrolysis, then it will be liberated at cathode. Same time, if you are doing AH, then water will be removed and it will be basic, pH more than 7, and it will be liberated on anode. And this deuter ion not liberated anywhere. This is called isoelectric point. Okay, so here you can write anode, ions liberated at anode. Okay guys, so this is the deuter ion. I hope it is clear to you. Next, so for that, how can you write? Mhm. So I am writing here all the three state: RCH, CO minus, NH2. They can be interconverted, H plus, OH minus, RCH, NH3 plus, then RCH, and here NH2 plus. Okay, so basic medium, what we have to write here, few points. Basic medium goes towards carboxyl ion. Okay, carboxyl ion, this ion. Acidic medium goes towards ammonium ion. This is your ammonium ion, okay? It is NH3. So what note you can write here? An amino acid never exists in an uncharged form. Okay, they never exist. Amino acid never exist in uncharged form. What is isoelectric point? For that, isoelectric point it's called pi, is a pH at which net charge of protein is zero. So what is the important thing, children? Isoelectric point is a pH at which net charge of protein is zero. Check it here, net charge is zero. So how to calculate? Isoelectric is equal to pk1 pk2 by 2. Okay, here this is k1 and this value is k2, k1 and k2, right? So this is the information. It's kind of theoretical things you can read and learn. Now, so definition of zwitter ion. The zwitter ion is an amphoteric ion. It is an amphoteric. It is an amphoteric ion, and during electrolysis it neither migrate neither migrates to cathode nor anode because it's an amphoteric. Example for alanine. For alanine, pK1 value 2.34 and pK2 value 9.64. Then find dielectric, sorry, isoelectric pi. It's very simple, children. So what is the solution? Pi is equal to pk1 pk2 by 2. This question is looks simple, but once it came in the JEE exam, this kind of question from dielectric, they will ask 5.99 is the answer, pi. So deuterion is completely finished now. Now come to the peptide. What is peptide? Peptides. So first definition, then we will explain. Proteins are large polymers proteins are large polymers of alpha amino acids. Such small polymer are called peptides. What is the definition, guys? Proteins are large polymers of alpha amino acids, and such small polymer are called peptide. You can say monomer of alpha amino acid. Okay. So next, these links are called peptide linkage. What it's called? Peptide linkage or peptide bonds. Okay, from where they connected, that is called peptide linkage or peptide bond. Okay, so what is peptide bond? This is a peptide bond. It's a amide group. Okay, in that case it is having strong resonance because double bond lone pair presence. So here strong resonance is present. All bonds about nitrogen lie in one plane. So the alpha amino acid have to form linkage. Okay, what I am thinking, children, this cannot be completed in 2 lectures. maybe one more lecture required. So here, this is the theoretical part of peptide and peptide bonds. So let's talk about the example, then it will be more clear. Definition once again I am reading. Proteins are large polymer of alpha amino acids. Such a small polymer are called peptide. These linkages are called peptide linkage or peptide bond. And this is the peptide bond. Strong resonance. All bonds about N lies in a planar species. So alpha amino acids to form linkage. That's it. In that case, so glycine H2 C double bond O OH and here NH2. It's alpha amino acid glycine, okay? And C COH here H and here one more H and here N. Sorry. With this C CH3 is attached and here nitrogen, two hydrogen of nitrogen. Alanine, what it is? Alanine. In that case, simply you have to remove water from here and peptide bond will be formed. See H2C, C double bond O, NH, C, CH3, H, COH, and here NH2 is attached. Here this NH2 is not here. So it is a dipeptide. Dipeptide. Two amino acid connected. It's a dipeptide. And this is your bond. Peptide bond. This is peptide link. Peptide link or peptide bond. What will be the name? Glycyl alanine. Mix it. Glycyl alanine. That will be the name. So definition, and this is the example, and it's a dipeptide. Similarly, tripeptide also you can form. So if two alpha amino acid, if you are combining two amino acid, then it is dipeptide. When three amino acid, then tripeptide. Four amino acid, then tetrapeptide. Many amino acid, then polypeptide. Okay, so this is the thing. Byproduct is water. So byproduct is water. Hydrolysis of peptide, if you are doing, hydrolysis of peptide, if you are doing, then they will decompose into amino acid. They will decompose into amino acid. Okay, so you can write here peptide n amino acid, n amino acid connected, and if you are using n minus 1 water molecule, then n amino acids formed. It's a simple thing. Here you are forming a peptide bond. So water removed and peptide bond formed. Two amino acid, dipeptide, tripeptide, tetra and polypeptide. Hydrolysis if you will do, then amino acid you will get. So that is the concept. What about polypeptide? Let's check it. Polypeptide. In the case of polypeptide, one unit I am writing, focus on it. CH, R1, C, N, H, CH, R2, C, double bond O, N, H, CH, R3, C, double bond O, N, H, and so on. This is the unit of polypeptide. So a few key points we are having here, you have to focus. What are the key points? Number one, the polypeptide are formed the polypeptide are formed so that R, R1, R2, R3, R's are as away as possible to reduce why? To reduce steric hindrance. The first peptide donates OH from COH, and the second donates H from NH2. And the third point, as resonance takes place along amide bond, we get trans configuration. So these are the points, children. Once again, I am explaining. Check it once. The polypeptide are formed so that R's are as away as possible to reduce steric hindrance. That is why their positions are far. The first peptide donate OH from COH and the second donate H from NH2. As resonance take place along amide bond, we get trans configuration also. So that is it for the today's lecture. In the next lecture, we will discuss about the structure of protein and we'll try to finish the protein as soon as possible, guys. So thank you, guys. Give your support, like the video, share the video. This side Govind the new 3, and thank you so much once again, and all the very best for your board exam and for your NEET and JEE preparation.